Welcome back to Statistics Tutorials with Excel. In this video we're going to take a look at the paired samples t-test along with the confidence interval, and I'm going to show you the functions in order to generate the output that you need to get the test statistic, the p-value, and then also constructing the confidence interval. So one of the things that you'll have to do first is make sure you have the data analysis tool pack added and installed on Excel. If you haven't already done that, make sure you do that before the video. There are other videos online on my YouTube channel that show how to do that. So in this scenario, we're taking a look at textbook prices that are available both online at a place like Amazon or something like that, and then your traditional bookstore, maybe at a university bookstore or something. And what we want to determine is if there is a difference in price between the bookstore prices and the online prices. So I wrote my hypothesis statements over here in these two cells right here so we could see those. So my null hypothesis will be the population mean of the differences is equal to 0. So when we say mu of the differences is equal to 0, it really means there's no difference between the bookstore and the online textbook or online retailers' prices. And when we say h sub a, mu of the differences is not equal to 0, this means there is a difference in price between these two retailers, the physical bookstore and then also the online retailer. So in order to do the hypothesis test, we have to know this general information right here, and it's fairly simple to do if you have the data analysis tool pack. So across the menu you'll choose data, and over on the far right side you should see data analysis. Once the dialog box pops up, you'll see that there's a variety of different things that you can do in here. And if you scroll to the bottom, you'll see that one of those items that are listed is the t-test, the paired two-sample for means. So that's the one that we want to select. Remember, this test is called either the paired samples t-test or the dependent samples t-test typically. So I'm going to go ahead and choose that, and then I'll say OK. And then the first thing it asks you for is the variable, so variable 1 and variable 2. Now, one word of caution, you have to think about the way that you're calculating the differences, and that's dependent generally on the alternative hypothesis. So we have a not equal to sign right here, which really, it doesn't matter which way we do the subtraction to calculate the differences. Later on, I'm going to do the bookstore minus the online. But if the subtraction is different, you have to pay attention to that. Like if I did online minus bookstore, variable 1 would have to be the online retailer. And then I would want to choose variable 2. That's what I'm subtracting from variable 1 in order to calculate those differences for this test. So you have to be conscientious about how that subtraction is done for calculating the differences. So for right now, I'm going to choose variable 1 as the bookstore prices. I'm even going to select the bookstore name right there. Once you select those, you'll hit enter. And then variable 2, I'll select as the online retailer. And then it asks for the hypothesized difference. Typically, this value is 0 for the paired samples t-test. There are special cases where it might be some other value other than 0. In this class, if you're taking the class with me, we're always going to use that difference as 0. Down here for the hypothesized mean difference, we're going to choose labels. We had labels in the first row of our variable, so we need to make sure that Excel recognizes that. And then the alpha value is our level of significance. I'm just going to keep that at 0.05 because later on I'm going to do a 95% confidence interval. And then we can tell it where we want the output to show up. And I'm simply going to select some cells over here just off to the right, and it'll spit all the output right there. And then once you're all done setting that up, just say OK with the dialog box, and then it should generate your output. So one thing I don't like about the output that's generated is it almost treats these as two independent samples when you look at the mean, the variance, and the observations. Really, we should be looking at the differences, but we're not necessarily going to use that. And we're not going to use Pearson's correlation or the hypothesized mean difference right here that you see at the bottom. And I'll make that a little bit larger. This hypothesized mean difference, this is the value we put in for the population mean of the differences. That's that value of 0 right there. And then next are the degrees of freedom. This value right here is our test statistic. So I'm going to highlight that so we see that. That's one of the values that we are after. And then it gives us our critical value. So it says T critical 1 tail, T critical 2 tail. This is if we're using the critical value approach where we compare a test statistic to a critical T value. We're going to be using the p-value approach in this class, so we want to pay attention to the probability of that t value being less than or equal to. And then it gives a one tail and a two tail. So we did a two tail test here because we have not equal to. So this is the p value that we want right here. Again, I'll highlight that so you see that. So that's our actual p value right there. Now, if you recall, we said our level of significance was 0.05. Well, that p value is smaller than that level of significance of 0.05. So that means we're going to reject h sub 0 and say there is a difference in textbook prices. So that gives us indication that there's evidence that these two organizations or these two retailers are different. One of them might be cheaper than the other, or one is more expensive than the other, depending on how you look at that. So the hypothesis test only tells us that there's a difference between these two retailers. If we want to see which one is more or which one is less, we can actually use a confidence interval in order to do that. So I'm going to show you how you would do the confidence interval. Before we can do that, we have to calculate the differences. So I'm going to create a new variable right here called the differences. And when I define the function for these differences, I'm going to do the bookstore minus the online retailer. That's how I'm going to calculate the differences. So I'll take this value and then I'm going to subtract off this value right here and go ahead and hit enter, and then that calculates that difference. So this value of 5 is really, when we do the subtraction, it's saying the bookstore is $5 more than the online retailer. So you have to think about these values right here in terms of the differences. If the values are equal to 0, that the differences of those two values are equal to 0, then that indicates that there is no difference between the price of the online store and the retailer for those specific textbooks. So an easy way to do this for all of the cells in this column is if you click on the cell that you previously created. So I'm clicking on that number 5 right there. You can see in the formula right there, it's giving the formula, and there's a little tiny box in the lower right hand corner. If you hover over that box, it makes a smaller plus sign, and then if you left click and drag down to the bottom of the rows, it'll automatically calculate all of those differences for each of these individual rows or each of these individual textbooks. So there's all of our differences right there. Again, if we have a positive value, it means the bookstore is that much more than the online retailer. If we have a value of 0, that indicates that there's no difference. And I don't have any negative values, but if I had a negative value, that would indicate that the bookstore is actually cheaper than the online retailer, the way that we set up the subtraction. So now we want to use this column right here in order to calculate our 95% confidence interval. So in order to do that, I'm going to go back to the data menu up here, and then I'm going to click on the data analysis tool pack. When this comes up, this time I'm going to choose the descriptive statistics option, and I'll say OK. It's going to ask me for my input. I'm going to select the column for all the values of the differences, including the variable name. My data is grouped by columns, and I have a label in the first row, so I need to check that box. And then I'm going to give it an output range for the output, and I'll just put that next to the paired samples t-test. I'll skip a cell and throw that over here, and I'll move over when it's time to view that. And then I do want the summary statistics. I also want the confidence level for the mean, and we're doing a 95% confidence interval. And I'll go ahead and say OK. Now you can see I have my output for the summary statistics for that column that we created for the differences. It's saying the sample mean of the differences is 4.3. This is our standard error. Remember, that's the standard deviation divided by the square root of the sample size. Here's our standard deviation. And then there's a bunch of other values here, but this is really the value that we're after right here. They label this as the confidence level, and I mentioned this in a previous video that this is actually the margin of error. So if you remember, a confidence interval is a point estimate plus or minus a margin of error. So technically we could just take this value and add and subtract that to this value of 4.3 to get our lower and upper bound. But I'm going to take a couple steps back and show you some of these calculations using formulas in Excel, just so you see those and you can reference those later on. So first of all, if we wanted to calculate our standard error, I can create a new function that says we're taking our standard deviation. So I'll select this cell right here. Then I'm going to say divided by SQRT, which is the square root function of our sample size, which happens to be the count right here. This is our sample size. And we had a sample size of 10. And when you get this, you get 1.491085, which you can see is the same value up here that we have for our standard error. If you want to calculate your confidence level, which they identify in here, which is really the margin of error, what you need to do is you need to take that standard error and you need to multiply it by the confidence level multiplier. So I'm going to show you how to get that next. So again, I'm going to start with an equal sign because I'm writing an equation. And the equation that we're going to use is we're going to use T dot INV. And the way that this function works is it uses a cumulative area from the very left of your distribution to the right. So I want the positive value of the confidence level multiplier, and if I'm doing a 95% confidence interval, that means the bounds, the middle section of that t distribution is 95%, but I also have 0.025 in each of the tails, so I'm going to use my probability as 0.975, all right? That'll give me the cumulative area from the left up to that upper value for the confidence level multiplier. The next input that I have to have are the degrees of freedom. Our sample size was 10, so my degrees of freedom are going to be 9. And then I'll close parentheses and hit enter. And this is my confidence level multiplier right there. So 2.262 is the confidence level multiplier. You could use a table and look that value up, and you would find it's the same value when it's rounded to 3 decimal places. The last thing I want to calculate is the margin of error. The margin of error is simply the confidence level multiplier times the standard error. So I'm going to say equals, and then I'm going to choose this value and then multiply that by the standard error, the 1.491. And that's going to be the margin of error. And you can see that this value right here that we got from the output matches up with that value down here that we just calculated. The last two things that we need to calculate are the lower bound and the upper bound. To calculate the lower bound, again, I'm going to write an equation. I'm going to say equals, and I already calculated the mean up here with the descriptive statistics, so I'm going to simply click on that value right here, and then I'm going to subtract off the margin of error. And it doesn't matter whether you use the one that we just calculated or the one that is given from the output from the table right there. I'm just going to use this one for right now. And then to calculate the upper bound, we're going to do the same thing. We're going to say equals, and we're going to take our point estimate, which is the sample mean, that 4.3. And this time we're going to add the margin of error to that. And this will give us our upper bound. So we can say that we're 95% confident that the population mean for the difference in price of the textbooks is between 92 cents or 93 cents and $7.67 on average. So that's giving us the estimate of how different those are. And because of the way that we did the subtraction, this means that technically the bookstore is slightly more expensive than the online retailer by about 92 cents to $7.67 on average. And this is making that inference about the population. So hopefully this video helps you out with confidence intervals and hypothesis tests using Microsoft Excel.